Assalamu alaikum dear students. Today we are going to discuss some standard limits. Yesterday we discussed the limit of a polynomial and the limit of a rational function. Now here the first limit is which is the standard limit. Prove that limit x tends to a x raised to power n minus a raised to power n upon x minus a is n a raised to power n minus 1, where a is the constant. Here x minus a raised to power n x raised to power n minus a raised to power n upon x minus a both are the polynomials, so this means that it is a rational function. When we put x equals to a in this given fraction, it simply becomes a raised to power n minus a raised to power n upon a minus a, which is 0 by 0. So it is the indeterminate form. By actual division, that is by long division method, this x, when we divide x n minus a raised to power n by x minus a, we simply get x raised to power n minus a raised to power n upon x minus a is x raised to power n plus a raised a into x raised to power n minus 2 plus so on to a raised to power n minus 2x plus a raised to power n minus 1, or which implies that x raised to power n minus a raised to power n upon x is x raised to power n minus 1 plus a raised to power n minus 2 plus so on to a raised to power n minus 2x plus a raised to power n minus 1. Now taking limits from both sides as x tends to a, that is limit x tends to a of this equals to limit x tends to a of this very expression, that is x raised to power n minus 1 plus a x raised to power n minus 2 plus so on to a raised to power n minus 2x plus a raised to power n minus 1. Now clearly it is polynomial, so its limit is simply obtained by replacing x by a. So this means that it is here a raised to power n minus 1 plus a into a raised to power n minus 2 plus so on to a raised to power n minus 2 into a, because here second last term is x, that is it is a raised to power n minus 2a plus a raised to power n minus 1. Now we simply equals to a raised to power n minus 1 plus, when bases are same, powers are added, 1 plus n minus 2 is n minus 1. So it is a raised to power n minus 1 so on to a raised to power n minus 1, but n times, which implies that it is n a raised to power n minus 1, because we have to sum up these a raised to power n minus terms up to n times. Hence this limit x tends to a x raised to power n minus a raised to power n upon x by a is n a n minus 1. Here the numerator term, that is x raised to power n minus a raised to power n, it is a polynomial, its degree is n. So when we put it in the given fraction a in this polynomial, it is simply 0, and in denominator we have 0 also. When we get this form 0 by 0 form, by substituting the given limit in the given this fraction or given this rational function, this form is called indeterminate form. Indeterminate form is that form which we have to determine, or which we can simply say that which we cannot determine in advance whether it is finite or infinite. Like if we consider it is 0 by 0, now here this 0 by 0 can be any number, because when we consider a by a, because for any number if numerator and denominator are same, then the value is 1, which implies that when we consider 0 and the numerator and denominator as a 0, so by considering this rule, that is numerator and denominator same value is 1, which implies that here value becomes 1. Now we know that for any fraction or for any p by q, when numerator is 0 implies that the result is 0, hence in this case it is 0. And if we consider for any number, for any fraction, when denominator is 0, the value is not defined, so this means that here it is not defined. So this means that it can be any number, whether finite or infinite. That is why this form 0 by 0 form is called as the indeterminate form, means which we have to determine. Like if we consider, find the limit of x to the x tends to 1, x raised to power 10 minus 1 upon x minus 1 equals to 10. Now here we can write this one as 1 raised to power 10, which is x raised to power 10 minus 1 raised to power 10 upon x minus 1. Now here a is 1, so limit x tends to a. X raised to power n minus a raised to power n upon x minus a, that is n is 10, a is 1, so it is n a n minus 1, that is 10 into 1 raised to power n minus 1, 10 minus 1, which is simply 10. So given limit is 10. Now if we consider limit x tends to 5, x to the power 2 minus 25 upon x to the power 3 minus 1 to 5. Now when we put x equals to 5 in given, it is 5 square, which is 25, which implies that numerator is 0. 5 cube is 1 to 5, which implies that 1 to 5 minus 1 to 5 is 0, so it is 0 by 0 form. So now we have to use the standard limit. Now this x square minus 25 can be written as x square minus 2 raised to power 5. 125 can be written as 5 cube. So dividing by x minus 5 to this numerator and denominator, that is x minus 5 and x minus 5 here, because they will cancel, we will get the given this rational function. Now limit of quotient equals to quotient of the limiters. So it is limit of x tends to 5, x square minus 5 square upon x minus 2 divided by limit x tends to 5, x cube minus 5 cube upon x minus 5. Here in the first in numerator this part, it is x square minus 5 square upon x minus 5, x tends to 5, that is a is here 5, n is 2, so it is 2 into 5 raised to power 2 minus 1, that is this. And in denominator we have x cube minus 5 cube upon x minus 5, that is 3 into 5 raised to power 3 minus 2, that is 3 into 5 square. Now 5 and 5 will cancel, we get 2 in the numerator, and denominator we have 3 into 5, that is 2 by 15. So 2 by 15 is the value of this limit, or simply we say that limit of this function exists at x equals to 5 and the value of the limit is 2 upon 15. So in this way you can solve the rational functions of any type, whether they are of 0 by 0 form or they are of any non-zero form. Inshallah, in tomorrow's video lecture we will discuss the standard limits of trigonometric functions. So thank you.